So right now we're going to look at how to solve compound inequalities. So if you remember from our lesson today, compound inequalities can come in two forms. They can come in an intersection, which you see here on the screen, or they can come in a union, which we'll do in a second. So this is an intersection, which means that we read it -10 is less than or equal to 3x plus 2, which is less than 11. So what we're going to do here is we're going to solve this inequality. So we're going to do that by looking at what's happening to my x. So if I forget about everything else here, I have 3x plus 2. So to get x by itself, I would need to subtract 2. Now, usually I say subtract 2 on both sides, but in this case, I have 3 sides here. So I'm going to subtract 2 on all 3 sides. So I have -12 is less than or equal to 3x, which is less than 9. And again, what am I doing to x? We're getting x alone. I need to divide by 3. So this time I'm going to divide all 3 sides by 3. And I have -4 is less than or equal to x is less than 3. So to graph something like this, let's get a number line here. One of my endpoints is on -4. That endpoint is a closed circle because there is a line underneath that inequality. And all it says -4 is less than or equal to x. So if I were to write my x first, look at how in this equality my inequality is eating the x. So I'm going to do the same thing over here. So that means my arrow is going to go up this way, right? Okay, so now I'm going to look at the second endpoint, which is 3. This is an open circle because there is no line underneath that inequality. And if I'm looking at x is less than 3, that means this number's under 3. So my intersection is everything from -4 to +3. So it is a line segment, which we talked about being intersections are always line segments. All right, so that's an intersection and how to solve an intersection. Here is a union. So with unions, you see the word or, and they have separate equations. So we're going to solve each inequality independently. So over here, I'm going to add 1 to both sides. I have 3x is greater than 3. Divide by 3. X is greater than 1. And then I always like to stick my or right there so I don't forget, because otherwise it just looks like 2 separate problems. That or is what makes it a compound. So over here I'm going to add 4. And I have 1/2 x is less than -6. To get rid of a fraction in front of a variable, we have to multiply by the reciprocal. The reciprocal just means to flip the fraction. So if I have 1/2 and I take the reciprocal would be 2/1 or just 2. So I'm going to multiply both sides here by 2. And then I have x is less than -12. All right, so on my number line, if I have to graph this, for sake of time, I'm just labeling every 2 instead of every single tick mark. All right, so I'm going to put a open circle on -12. So -12 has an open circle. And it says is less than. So I'm going to do numbers less than -12. So I point that direction. Here I have x is greater than 1, so I'm going to do an open circle again because there's no line underneath on 1, and I'm going to do a line the opposite direction because it's greater than 1. So my unions look like 2 independent rays. So there you go. We have just solved 2 compound inequalities, both intersections and unions. Hopefully that kind of clarified some things for you.